Okay, so we are discussing SQL. Okay, so in the previous class we have discussed about SQL. Let's revisit what we have discussed. Okay, first, what is the full form of SQL? It is structured query language. It is developed at IBM Research for System R, and it is basically include the feature of relational algebra, relational tuple calculus, and it is a standard for relational database access, and it is DBMS independent. Means what kind of DBMS you are using, it doesn't matter. The SQL structure are the same for all kind of DBMSs, and it is both. Means it is DDL and DML. DDL means using DDL language we define the structure of table, structure of column, or we can set the domain of column. We can some kind of enforce the integrity. We can set primary key, foreign key. Means this kind of structure we can define using DDL, and the DML, using DML we can access the data, or we can apply the change over our data. Means we can insert record into our table, we can delete a record in table, we can update the existing record in table. This kind of operation we can perform using DML, data manipulation language. So SQL is both DDL as well as DML. These are the basic terminology in the relational algebra. We call relation, and here in SQL we call as a table. A tuple is a record. We called as a row in SQL. Attribute we called in relational algebra. Now we call as a column of the table. Okay. First, we in the DDL, data definition language, first we create table. So creating a table, there is a command create table, relation name and description of the attribute or column. Okay, these are the some domain you can define for your column: character, where char, int, numeric, float, date, time, stem, and or even you can create your own data, own domain of the column as well. Okay, using these keyword. You can set some kind of constraints for the column, like not null. Means if you set null constraints, means the value of that column you cannot leave blank, you have to enter any value for that column. Default, you can set some default value. If you not mention any value for that attribute or column, by default it took some values what you define. Unique means all the value of that attribute must be unique. No two values for that column having the same way. Okay. Primary key, you can set attribute or list of attribute as a key of that table. Foreign key means you can set some attribute as a foreign key that which refers some other relation or some other table. Okay, this is one example of how we create a table. Like you can see on your screen, we create a instructor table using command create table, and id is one attribute. The domain of this id attribute is char. 5 is the maximum the fixed length domain, which is 5. Okay, name is second attribute, which is varchar. The maximum length of this uh, attribute is 20 character. Okay, and not null means you cannot leave name attribute blank. Okay, means always you have to enter the name of instructor. Department name is next attribute. The domain of this attribute varchar, again the length of this uh, attribute is 20. Salary is another attribute of this table, and the domain of this is numeric 8 comma 2. 8 comma 2 is there's an 8 total 8 digit, and after dot there must be 2 digit. Okay, so total 6 digit before this dot, and after dot 2 means total 8 digit in your salary. Okay, the primary key of this table is primary key of this table instructor is id. You said id is a key of this table instructor, and a foreign key for this table is department name. Department name is a foreign key which referring a table department. Okay, means the detail of this department is exist in the department table. These are some other examples as well. We have discussed everything, and now how we can insert the record into our table using insert into command. Insert into, then mention the table name in which you are inserting the record and what is the value of that record. Okay, follow the order in which the table is defined, like id, name, department, and salary. So you have to follow the structure, or the sequence of attribute. Okay, and if you want to change the sequence of attribute, you can use insert into table name, and what is the changed order you are changing, and then enter the values. Okay, and multiple record you can also at the same time, like insert into employee values and separate each record by comma. Okay, and the next we have seen saw in the last class is delete. How we can delete record from the table using delete command. Delete from which table you want to delete the record, and what are the condition, on which condition you are deleting record, like delete from employee where condition is where employee number is 007. Okay, so the record which employee id is 007, that record will be deleted from the table employee. Okay, or if you want to delete all the record of the table, you just write delete from. Do not pass any where condition. How we can delete a table? To delete a table, the command is drop table and the name of table, which table you want to delete. And in this square bracket there is some command is written. It is optional, that is dependent. You can pass the dependent cascade and restrict. In the cascade, if you want to delete this table and it is referring some other table, then that table also will be deleted. In the restrict, if you are referring some other table and if write independent restrict, so it will check if there is a dependency of the other table, it will restrict you before deleting. It says first remove the dependency, then it can delete that table. Okay, and same way how we can modify the structure of table which already we have created. So there's command is alter table your table name and add. Suppose you want to add some more column into your table, so you will write alter table relation name add your new column name with the domain of that column. Like here we have mentioned for example alter table name is employee. We are adding a new column which is qualification, and the domain of this qualification attribute is varchar 20 characters. And how we can delete an attribute from a table is alter table name, drop, and column name, which column you want to drop from the existing table. So till now we have seen this kind of command. If you have any doubt till this point, you can unmute yourself and you can ask. If you have a doubt in the previous class, you can ask. Okay. If you do not have any doubt, we can start. The basic query structure is select from where. Select the you mentioned the list of column which you want to retrieve. In the from clause, you write the relation name from which relation or relations you want to retrieve the record or information, and where in the where clause you will mention the condition on what condition you want to retrieve the record. Okay, so select from where. There is a three clause. Select from where. Like we have mentioned one, we have write one simple as query. Select name from instructor. So there is one table instructor. In the instructor table, we want to retrieve the name of instructor. So select name, all the name of instructor from the instructor table. So it will retrieve, it will give you all the names of instructor. Okay. In SQL, and there is a difference in SQL and relational algebra. The query result, what you get from SQL and relational algebra. In the relational algebra, it remove duplication. Okay, suppose you write the same queries in relational algebra, then you will write sorry, in relational algebra you write project name from instructor. So what the result this query will give you, it remove duplication. If two instructor having the same name, so it remove that name which is duplicates. Okay, means it do not contain duplication. Okay, but SQL, SQL contains duplication in result. If two or more than two instructor having the same name, so it will give you both the names. Okay, suppose in your instructor relation there's two instructor having the same name Rahul, so it will give you Rahul twice in a resultant table. Okay, but in relational algebra it will give you only one time Rahul in your resultant relation. Is it clear? In SQL, it contains duplication, but relational algebra does not contain duplication. Okay. And next key point you can say is it is in case insensitive. Okay. What the name you can write as name in capital, or the first letter you can capitalize, or you can write select as like this. Okay. Select name and from instructor. So what the point is? SQL is the case insensitive. Okay, you write SQL or in a small letter or capital letter, doesn't matter. Let's see one more query. If I ask, give me the name of employee from the uh, give me the name of employees from the relation employee. So what you will write? Select name and suppose in the name there's an we can subcategorize is the categorization of name is first name, middle name, last name. So you will write select f name. Okay, 1 minute. I'll just write select. You want to retrieve f name, first name, middle name, and last name. So last name from the which table you want to retrieve? Employee. Okay. So in this way, you can write the query for retrieving the name of employee from employee relation. Okay. Is it clear? Am I clear to all of you? Please write in chat or unmute your mic and speak if it is clear. Okay. Okay. So as you know, okay. As you know, SQL allows duplicates in relation. So how when suppose we want to remove duplication from the relation. So how means as you know, SQL allow duplication, but in some queries we want to remove duplication. So we use the keyword distinct in our query. Okay. Suppose we want to retrieve the distinct department name. Okay, from the instructor table. So we will write select distinct department name. Okay. So in this case, it will remove duplication. Okay. 1 minute. There's a call. No? So in this way, we can remove duplication from our resultant table. Okay. Okay. Or if you do not want to remove the duplication, you can even use the keyword all. So it will contain the duplication. If you not mention the all, it is implicitly include duplication. Suppose you want to retrieve all the column of the table. Suppose you want to retrieve all the column of the table. So if you can write all the column name in this select clause, or you can write even asterisk. If you write the asterisk, it will include all the columns in your resultant table. Okay. So as you can see this query, select asterisk from instructor. So what are the column of instructor? It will retrieve. Okay. Suppose in your instructor there is a column ID, name, salary, and department. In which department the instructor is working. So all these four column it will retrieve, and the resultant record it also in the resultant table. So asterisk says that all condition, all is in all the columns of that table. In the select clause, you can apply some operation, arithmetic operation. You can apply in the select clause. You can apply some kind of arithmetic operation as well. Okay, like here, I write one query. In this query, I retrieve ID, name, and salary divided by 12. Okay, from the instructor table. Okay, so suppose you are in instructor table, the salary is mentioned annually. Annual salary is mentioned in your instructor table. So what you want to monthly salary or the month salary of that instructor. So you just write the query ID, name of the instructor, and salary divided by 12. So in this resultant table, you will see the monthly salary of the instructor. Okay. So this is a kind of operation you can apply over select clause. Is it clear? Or suppose you retrieve this column and you want to change the name of this column, so you can use as keyword. Using as keyword in SQL is rename the column. So we can rename using as keyword. As you can see in this query, I just tried select ID, name, salary divided 12 and as monthly salary. So in the resultant table, it will give you the table like ID, name, and third column will be monthly salary. Means here I just change the column name using as keyword. Okay. So this will be the structure of your resultant table. Okay. There is a three column ID, name, and monthly salary. If you not write this, there is a column name will be salary. So as is the keyword which rename the column. The next is where clause. Where clause. In the where clause, you can pass the condition or predicate on which you are retrieving the record from the table. Okay. Suppose you can see one query here on your screen. Find all instructor name in computer science department. Means you want to find the name of instructor of computer science department. So what the query you will write, select, you just want to the name of instructor, so you will just write one column name, from which table, instructor, and on what condition, where department name must be equals to computer science. Okay. Okay. So in this way you write the queries in SQL. Select what attribute you want to retrieve, where, from which table you want to apply this query, and in the where clause you mention the condition or predicate on which you are retrieving the record from the table. Okay. So when you run this query, it will first it will run it will execute where sorry from clause. Means it will first find the name of table, or the table in which you are going to apply the queries, then what the condition you are passing, and third what are the column, or in which column you are interested. Okay. So this is the order in which SQL queries execute. First, from clause will execute. It will identify which table or tables are the input for this query. In the where clause, you pass the condition on what condition you are getting the result, or getting the result, and third is in this resultant table what are the interested column. Okay. In which you are the column in which you are interested. This is the general form how SQL query execute. Okay. In this where clause, you can pass some logical connectivities or logical operation you can apply, like and or not. Okay. Like here you can see the next query. Here I just find the name of all the instructor of computer science department whose salary is greater than 80,000. Okay. So you can find all the instructor in computer science department with salary greater than 80,000. So how you can write the query for this? How you can write the SQL query for this? Okay. So first, from which table you want to retrieve this information, from instructor. So as you can see this query, first from which table you want to retrieve the result from instructor table. So you just write from instructor. What is the condition? Department must be computer science. So you just write department name equals to computer science in single quote. Always this what the string you pass in a always in single quote. Department name must be equals to computer science, and the connect this logical connectivity is and this salary greater than 80,000. So we have passed these two condition and combine these two condition using this and operator, where department must be computer science and salary must be greater than 80,000. And from this resultant table you just find the name. This is only you are retrieving the name, so you mention that attribute in select clause. If you want to retrieve more than one column, you just separate it by the comma. Okay, name and you just cite ID. Okay. Separated this column by comma. Okay. If you want to retrieve all the column of that table, you just simply write asterisk. Means what are the attribute of this instructor? All this attribute will be resulted in this resultant table. Is it clear? This query is it clear to all of you? If you have any doubt till this point, you can unmute and speak.
सर
Yes,
हेलो
please.
सर सर रीनेम के लिए आपने बताया था एस तो हेलो
हाँ सुमन बोलो. सौरभ.
सर एलियासिंग का कॉन्सेप्ट कहाँ यूज होगा
एलियासिंग का
हम्म
एलियासिंग ही बोल रहे हो ना आप?
यस सर
Aliasing when we want to change the name of table. Suppose in this case we are using only one table instructor. In this case there is no need
ओके
for aliasing. If we want to
ओके
change, suppose here instructor table, one minute, just
हम्म
please listen. If suppose I want to change this table name instructor as I, capital I. So now
यस सर
the table name will change as I. Okay. So
ओके
this is the aliasing, means using aliasing we can change the table name or column name as well. Suppose you want to change the name column as uh, instructor name, I name. Okay.
हम्म
Okay. So this is the using as keyword we can change the name or attribute name, or even you can change the table name. Okay, we will see the aliasing in some one or two slide. Okay, then you will it will more clear how we can use actual in our SQL.
ओके सर थैंक
Okay, Saurabh,
यस सर
is it clear, Saurabh?
यस सर
Okay. Now the from clause. In the from clause, we mention the input table. Input table, you can say in which table we are applying SQL. Okay. So from in the from clause, we mention only table name. Like here, you can see I just write two input table, instructor and teachers. Okay. So from table, you always mention that table name in which table you are applying SQL. Okay. Suppose you are entering two table name in from clause separated by comma. Okay. Suppose you have mentioned two table name in from clause separated by comma. Before SQL execute or start execution, it will automatically apply the Cartesian product over these table. Like instructor and teacher, first it will compute the Cartesian join or Cartesian product of these two table. Then the next clause will execute, like from or where. Sorry, where or select. Okay. So using from clause, we mention the input table or relation. Okay, so the from clause lists the relation involved in query. Okay, so the corresponds to the Cartesian product operation of the relational algebra. Okay, so generates every possible instructor and teacher's pair. If we pass these two table as input from clause. Okay, so in the next, as you can see here, our first table instructor, these are the entries or this the records of this table, and teachers, the teachers table, these are the record. Okay, when you write from instructor comma teachers, okay, so when you write these clause, so it will apply Cartesian product. First it will apply the Cartesian product. I'm sure everybody knows how to apply the Cartesian product. Okay, it combine each record of the first table with every record of other relation. Okay, this is the, in this way we apply the Cartesian product. Okay, took the each record of the first table and combine or join with every record of other relation. In this way you will get this resultant table. Okay, then we will apply our query. Means now this is our now this is our input table. Okay, after getting the Cartesian product of these two table, instructor and teachers. Okay, in the instructor table there are column are ID, name of instructor, department in which department is the instructor is registered for, and salary of the instructor. In the teachers table, the columns are ID of the teacher or the instructor, course ID in which this instructor is teaches teaching, and it's a section ID, and in which semester the this course is fall or occurring that in which semester the course is occurring, or what are the years of that course. So these are the two table with these detail. Okay, this combine, the combining relation will like this. Okay, now the query, you can see, find the name of all instructors who have taught some courses and the course ID. Means you want to retrieve the name and course ID of the instructor who taught some courses. Means you must taught some courses. Okay, there's no means we want to find the name and course ID of the instructor who is taughting some courses. Okay, means, okay, so how we can find? First we need two detail of the two tables. First, name and course ID you required, so must be instructor table should be the input. Okay, because the name is mentioned in the instructor table. Okay, and the condition is must be teaching some courses, so the teaching record of teaching is available in this teachers table. Okay, so you must combine these two table. Okay, so means the input of this relation will be this two table, instructor and teachers. The condition is must be teaches some courses, means the course ID must be available in this table teaches. Okay, these are IDs are mentioning or mentioning that this instructor is teaching some courses in some semester and in particular year. Okay, so this id must be present in this teachers table. So you just want to name of that instructor which is teaching. Okay, okay, so this id, this teaching id and course, so instructor id must be same. So this is the condition in which you are applying this SQL. So where the instructor and teachers are the input relation or the input tables, and the condition is instructor ID equals to teacher's ID. Okay, it must be equals. Then give the name and course ID of that resultant relation. Okay, once more. See, this ID must be equals to this ID. Okay, means there is a presence in the teachers table. This id must be present in teachers table. Okay, so only those records, so like this here it is equals. So that's Srinivasan is the person who teaches some courses. Okay. As you can see, this 1 2 1 2 1 is similar, means the same. So this W, whatever the name is, okay, is teaching some courses. Okay, means it will retrieve only those record where instructor ID must be equals to teacher's ID. Okay, is it clear to all of you what the meaning of this query? Okay, is it clear? Means the queries is saying remove the instructor who is not teaching any courses. This query is saying remove those instructor who is not teaching any courses. He is present in instructor table but is not teaching any course. Okay, in the institute or the college. Okay, so this using this query we can get that kind of name of instructor. Okay, the next query, as you can see on your screen, is find the name of all the instructors in art department who have taught some courses and course ID. Means we want to find the name of the instructor who is belongs to art department and he is teaching some courses. Okay, so from select from instructor and teachers are the input table, and the condition is the same as what you passed in the previous query. Instructor ID must be equals to teachers ID and instructor department must be equals to art. Okay, so it's the same as, but the difference is that instructor must be belongs to art department. So you just add one more condition here with the end clause. Means both this condition must be satisfied. Then you will retrieve the name and course ID of that instructor. Is this query clear to all of you? Is this query clear to all of you? Both the queries? Okay, let's move. If it is clear, then let's move to the next slide. Rename operation. As Saurabh asked, how we can use rename or aliasing. Aliasing. So SQL allows renaming relation and attribute using as clause. Or we can apply this. Just write the old name as new name. Just write the old name of the column or table, then write as and change mention the new change name of that column or table. Okay, so in this query you can see the first read what is the queries. Find the name of all instructors who have a higher salary than some instructor in computer science. Again, I'm just reading. Find the name of all instructor who have higher salary than some instructor in computer science. Means this query says, give me the name of instructor who is getting salary more than the salary of the computer science department instructor. Okay, so how you can write this query? First, see the from clause. Now, as you can see, I just write instructor as T. Means here I just change the column name. Sorry, table name. The instructor is the old name of the table. Now I'm just calling this table name as T. Means the newly changed name of this instructor table is T. And again, I just write instructor as S. Now again the same table I'm changed as S. Now we have two table T and S. Now we have two table T and S. In the T table, the table T having the same structure and record of the instructor. This is the table is same as instructor, and S is also the same table. The attribute name and record all are the same as instructor. Means now we have the two table T and S having the same values. Okay, means it's the identical records in both the tables. Now we are passing the condition in where clause. Where clause in we says T dot salary. T dot salary must be greater than S dot salary. The first condition we passed, T dot salary must be greater than S dot salary. Means always the salary of this relation or table greater than the salary of the table S. And the second condition is department name equals to computer science. Just always you want to mention, you just want to mention the department must be equals to computer science. Okay. So just consider, if it's not clear, don't worry. Just say there is an employee to sell A, B, C, D, four employees, and there is some salary 100, 200, 250, and just consider 150. Same record is present in this table as well. 100, 200, 250, and 150. And the employee name is also same A, B, C, D. Just consider. When you apply the Cartesian product of these two tables, here as you can see, from bare class you pass two tables T and S. Definitely it will Cartesian product of these two tables. This with all the record of the other table as okay as this. So here the first just took the first record and apply the Cartesian product. Condition is T must be greater than S. Here 100 is greater than 100. No, so this record will not in your resultant relation. 100 is greater than 200. No. 100 is greater than 200. No. 100 is greater than 50. No. So no relationship between with these first record with any of the other record. Now took the second. 200 is greater than 100. Yes. So this record in our resultant Cartesian product B 200. Okay. And 200 is greater than 250. No. 200 is greater than 150. Yes. So this also will be in your resultant relation 150. Okay. So two record of this with this record 2 C 250 is greater than 100. Yes. So C A 100. C is sorry 250 is greater than 200. Yes. So C D 200. Okay, sorry, this is not B. Okay. And now C 250 is greater than 150. Yes, C D 150. Okay. Now, in this way, you can establish the relationship, and only those record which T salary is greater than S salary, with that consider and check the next condition. Computer science must be department name must be computer science. Okay, then retrieve the name of instructor T dot name from the T table. This column name will retrieve. Okay, as you can see in this table, there is a T dot name and S dot name. So you are just retrieving this T dot name, not S dot name. Okay, this query is clear. Is this query is clear to all of you? If it is clear, it is good. So please write the attendance for this class, and I'm just closing this meeting.